Now starting the lecture, lecture number 37 for the classical mechanics, that is the Coriolis force. We're going to discuss under the classical mechanics, and that is related to the rotational kinematics of the rigid bodies. That is the course of BS 5th, and the course code of your subject is PHY 509. The Coriolis force, the definition of Coriolis force is in physics, the Coriolis force is an inertial or the fictitious force that acts on an object in motion with a frame of reference that rotates with respect to an inertial frame. In a reference frame with the clockwise rotation, the force acts to the left of the motion of the object, that is called the Coriolis force. To understand what is the Coriolis force, we have to discuss the history. French physicist Gustave Gaspard Coriolis, 1972 to 1843. He was a French physicist. He published a paper in 1835 on the energy of yield of mechanics with the rotating parts. Number 3, Coriolis referred to this force as the compound centrifugal force, and by 1920 it has been named as the Coriolis force. For the evidence of rotation to understand the Coriolis effect, the tendency of the objects moving over the earth, air, water, planes, projectiles to be deflected in the curved way from a straight line path, the French physicist Gaspard Coriolis first explained the deflection of the objects moving over the surface due to the earth's rotation. The deflection is to the right in the northern hemisphere and to the left in the southern hemisphere. This deflection occurs because the Earth's surface is rotating um, with respect to the objects. Here you can see in the picture A, the expected path is a vertical of that the gunshot, but the actual path followed by the gunshot is the curved path, that is projectile fired on the northward, and the projectile uh, fired on the southward. The expected part is downward, vertically downward, but the actual part is in the curved path on the right hand side. Is also called the Coriolis effect. In classical mechanics, an inertial force described by the 19th century French engineer mathematician Gustave Gaspard Coriolis in 1935. Coriolis showed that if the ordinary Newtonian laws of motions of the bodies are to be used in a rotating frame of reference, an inertial force acting to the right of the direction of the body motion for counterclockwise rotation of the reference frame or to the left for the clockwise rotation must be included in the equations of the motions. That means the for the curved paths, the rotations are not straight, but they are on the curved path. In the previous picture, you saw the actual path, but in real case, uh, that is the case when the curved paths tend to rotate the paths of the um, motion of the winds and airs for the earth. Here you can see the North Pole projectile. A hockey puck is launched from the North Pole. As it heads south, uh, the Earth turns to the east, causing the puck to appear to deflect to the west as viewed by the Earth-bound observer. Legend: red, path on rotating the Earth; grey, path on stationary Earth. So for that, by this we can say that the Coriolis effect is the tendency for any moving body or above the Earth's surface, e.g. an ocean current, wind or an artillery round, to drift sideways from its course because of the Earth's rotation. That is called the Coriolis effect. You know that the true shape of the Earth is not circular, but it is an oblate spheroid. The diameter from the North Pole to the South Pole, the shortest diameter, is approximately 12,714 km. The equatorial diameter, the longest diameter, is approximately 12,756 km. This is not a big difference, but it does make the Earth not quite a sphere. So, for this, we can say that the effect of the Coriolis force is an apparent deflection of the path of an object that moves within a rotating coordinate system. The object does not actually deviate from its path, but it appears to do so because of the motion of the coordinate system. The Coriolis effect is most apparent in the path of an object moving longitudinally. On Earth, an object that moves along a north-south pole path or longitudinal line will undergo apparent deflection due to the right in the northern hemisphere and to the left in the southern hemisphere. Here you can see the effect of the Coriolis force. Non-rotating Earth, there is the north pole on the above side. You can see the launch side is on the above side. The target is at 0 degree angle. On the left hand side there is an Atlantic Ocean, and the right hand side that is Africa, and on the horizontal line there is Asia on the right hand side and North Antarctica on the left hand side, and on the back side or the above side of the is the Pacific Ocean. Now the Earth is rotating 50 degree each hour. So the actual path we launched is a straight path, but as the Earth is rotating at 50 degree angle to the right, then it means that the path of rotation is from the left to the right. The target has to move on the straight path, but it appears to move in the curved path. That is the actual destination of the path that is under the Coriolis effect of Earth's revolution around the Sun. First is a seasonal constellation because of the Sun's annual motion. Some constellations are visible at night only during the certain seasons, and the constellations are visible when the dark side of the Earth, away from the Sun, faces towards the constellations. Here you can see the different pictures depicting the effect of the Coriolis effect on the different weathers. That is the thundering, raining, and the tornadoes. These are the severe weather effects of the Coriolis effect. Hurricanes, thunderstorms, and the tornadoes are the effects that are studied under the Coriolis effect. For that, the reasons are for this phenomena. First, the Earth rotates eastwards, and the second is the tangential velocity of a point on Earth is a function of the latitude. The velocity is essentially zero at the poles, and it attains a maximum value at the equators. Thus, if a cannon were fired on northward from a point on the equator, the projectile would land to the east of its due to north path. This variation would occur because the projectile was moving in eastward faster at the equator than it was its target further north. Similarly, if the weapon were fired towards the equator from the north pole, the projectile would again land to the right of its true path. In this case, the target area would have moved eastward before the shell reached its because of its greater eastwards velocity, and exactly similar displacement occurs if the projectile is fired in any direction. The Coriolis deflection is therefore related to the motion of the object, the motion of the Earth, and the latitude. For this reason, the magnitude of the effect is given by 2v omega sine phi, in which v is the velocity of the object and omega is the angular velocity of the Earth and phi is the latitude. It is also an important consideration in the ballistic, particularly in the launching and the orbiting of space vehicles. In modern physics, applications of quantity analog to Coriolis force appears in electrodynamics wherever the instantaneous voltage generated in the rotating electrical machinery must be calculated relative to the moving reference frame. This compensation is called the Christoffel voltage. The Coriolis effect has greatest significance in astrophysics and stellar dynamics. in which it is a controlling factor in the directions of the rotations of the sunspots. It is also significant in the earth sciences, especially meteorology, physical physiology, and oceanography, in that Earth is a rotating frame of reference and the motions over the surface of the Earth are subject to the acceleration from the force indicated. Thus, the Coriolis force figures prominently in studies of the dynamics of the atmosphere, in which it affects the prevailing winds and the rotations of the storms, and in the hydrosphere, in which it affects the rotation of oceanic currents. As the Coriolis effect has a severe weather effect, so the ingredients for the storm are the heat from the sun, differences in the air pressure and the water. As the hurricane is also under the Coriolis effect, so we'll discuss about the hurricane, how they are formed. A hurricane is a large swirling low pressure system that forms over the warm Atlantic Ocean. What does a hurricane need? Number one, warm ocean water more than 80 degrees Fahrenheit provides energy for the hurricane and causes more evaporation, making humid air and clouds. Number two, winds coming together force air upward. Number three, wind flows outward above the storm, allowing the air below to rise. Number five, Number four, humid air rising makes the clouds of the storm. And number five, light winds outside the hurricane shear it and let it grow. That is the hurricane formation. Hurricanes form over warm ocean water. Number one, near the equator, warm ocean water provides energy that can turn a low pressure center into a violent storm. Number two, as water evaporates from the ocean, energy moves from the ocean water to the air. This energy makes warm air rise faster, tall clouds and strong winds develop. As wind blow across the water from different directions into the low Coriolis effect bends their path into a spiral. The winds blow faster and faster around the low, which becomes the center of the storm system, as you can see in the picture. For the Coriolis effect, the parts of the hurricane are here. That is the outflow of the air and the descending of the air in the curved path, warm air in the center, the eye of the hurricane, and the spiral rain bands around the hurricane. The structure of the hurricane, you can see the eye at the center, the spiral rain bands around the hurricane structure, and then eye wall around the eye, and the counterclockwise rotation of the hurricane. And for the parts of hurricane, why is the hurricane? What is the eye? The calm center point of the hurricane. Eye wall is the wall of dense thunder clouds surrounding the eye. The strongest winds of the hurricane are in the eye wall. Spiral rain bands are a series of long spiraling bands of rain clouds in a hurricane. When the hurricanes appear, why do hurricanes seem to die over land? As long as the hurricane is over water, the warm, moist air rises and provides energy for the storm. But when a hurricane reaches land, however, its supplies of energy disappears and the storm loses power, so the hurricane seems to die over land. The other example of Coriolis effect are the tornadoes. Tornadoes form from severe thunderstorms. They are very destructive because they have a high energy density. They also don't last very long. This makes it hard to learn about them. Since scientists don't know much about the tornadoes, it's also hard to forecast them. In severe, the thunderstorm wind at the different heights blow in different directions at the different speeds. This difference in wind speed and direction, called the wind shear, creates a rotating column parallel to the ground. A thunderstorm's updraft can tilt the rotating column upward into the thunderstorm, creating a funnel cloud. If the kernel comes into contact with the Earth's surface, it is called a tornado, as you can see in the picture. Here you can see the picture for the thunderstorm. Thunderstorms are small, intense weather systems that produce strong winds, heavy rains, and lightning, and the thunder. These all examples are under the Coriolis effect. The question is, when do the thunderstorm occurs? Thunderstorm occurs from warm, moist air and along the cold fronts. You can see in the picture that on the left hand side the cold fronts are traveling to the right, and the warm, moist air is traveling in the upward direction. How are the thunderstorms created? There are three ingredients for the thunderstorms to be created. The earth surface must be warm and moist. It rises or moves upward, which is called a updraft. Number two, the atmosphere must be unstable. The surroundings is colder than the rising air mass. As the warm air mass rises, it cools and turns into the water vapor, condenses and forms uh, colum- cumulonimbus cumulus clouds. Cumulus clouds. Now, the Coriolis effect on the ballistic trajectories. The Coriolis effect causes the Coriolis drift both horizontally and vertically. The deflection in the north hemisphere to the right, south hemisphere to the left. For eastward shots upward, uh, uterus. For westward shots downward effect, and that is upward and downward is called uterus effect. Ballistic projectiles with long flight time. It is a significant factor in the calculating the trajectories. These are the references for the topic. You can get the help if there is any kind of need, or you can ask the questions regarding the topic in the physical class. Thank you so much. Hopefully the topic under the rotational kinematics, the Coriolis effect is clear to you. Thank you so much. Hopefully there is no kind of problem in the topic. If there is any kind of problem, you can ask me. Thank you so much. Allah Hafiz.